Hi, this is Physics 1, and we're doing Chapter 3. This will be the vectors portion of it, and it'll be Part 3. Um, and we had started looking at, we got into depth in looking at some trigonometry for vectors. As I told you, vectors are very important. I know I told you that because I just said it 5 minutes ago in my time. Because I literally just started the next video right after that. And so, yeah, this is going to be very important. And so we're going to keep going through these kind of almost a recap of it in a sense, but recap using physics language and physics term. So here we're looking at a velocity vector. It's going to be 15 meters per second at 30 degrees, which I didn't put degree, but I put the angle, so that sign is the angle sign. I don't usually use that often, but I don't know why I did it here. I may just copy that from somewhere. No, it looks like it did. I don't even know how you put the angle sign in. Okay, anyways, it's late. It's like 2:30 right now in the middle of the night because I have to do these when my kids are asleep. Otherwise, yeah, it's not easy to think at that point. Um, I actually think clearer now. Nobody's awake. Yeah. So, anyways, I just went through a video that I was for a class I'm taking because I'm taking some graduate level classes, and they're all online. And so the guy makes the videos just like kind of I'm doing. He uses different programs, whatnot. But he had gotten into saying how it's kind of cool being able to just sit here and teach in my gym shorts. I'm not in gym shorts. I'm not in pajamas. I got jeans on. But um, yeah, you guys have no idea that it's 2 a.m. here at this point while I'm making this video. And I got sleep early, so I'm not like super tired or anything. I'm a night owl. Okay, so we won't break things down into components. Cosine theta is going to be Vx over Y. Why? Well, Vx is always going to be your X component. That's why we call it, put a little X symbol there, so it tells us this is our X component. Vy is going to be your Y component. And V, and I don't know why that thing pops up, but V is going to be your resultant, or sometimes we call it VO. It depends on what vector we're looking at. I mentioned in one-dimensional that VO is the initial. So if we're looking at the initial velocity, it's going to be VO. If we're looking at the actual velocity, it's going to be just V, right? So these have VOs because it came from something that was supposed to be the initial velocity. So don't get too caught up in the fact that that's a VO. It works the same way no matter where we're at. For example, if I wanted the velocity here, which is going to be like this, you're going to have a Vx and a Vy. Now, I'm not going to call that VO because VO is designated as the beginning velocity here. Right, that's why we say it's VO because it's at the beginning. So VOX, VOY. But they're both found the same way. And it's that velocity, that resultant vector, the actual velocity that would be on a speedometer as you're traveling, telling you how fast you're going, is what this V is, or VO is. When we break up into components, cosine of that angle is going to be Vx over V, since adjacent over hypotenuse. And so Vx is V cosine theta. Vy, or I should say sine theta, is going to be Vy over V. Why? Because sine theta is going to be opposite Vy over your hypotenuse. So Vy equals V sine theta. And then tangent, I'll write down here, tangent theta is Vy over Vx. So Vy over Vx, which is y over x. And then V squared is still Vx squared plus Vy squared, since these are the components. So Vx squared, Vy squared equals V squared. Just Pythagorean theorem. Alright, so the key thing is when we're using these, again, we break the initial velocity down into components, and so we use these that way most of the time. We use the tangent when we're taking and we're bringing them back together. Usually if we're solving for a downwards velocity. You know, I probably will have Vx and Vy at this point. And so to get the V at this point, which I'm going to call it final, I would need my Pythagorean theorem, I would need my tangent. Right, so I do remember SOHCAHTOA, but that's not how I tend to remember my trigonometry. It's just, I've done this so much that this sticks better. X, Y, and then some vector, which could be V if it's velocity, it could be F if it's force, it could be P if it's momentum. And then figure out the trigonometry ratios from there. Cosine is X over V. I know I have an A here, but I'm going to call it V. Okay, cosine is X over V. Sine is Y over V. Tangent Y over X. Now, that's from theta. If I flip it, I'm looking at that angle. Then sine phi is X over V. Cosine phi is Y over V. Tangent phi is X over Y. And so just like I did before, I can solve for X, I can solve for Y. I can solve for them in terms of theta or in terms of phi. And if you notice, they're the exact same form. And then the inverses are exactly done the same way. Cosine inverse of X over V will give you theta. Sine inverse of Y over V will give you theta. And tangent inverse of Y over X will give you theta. And then sine inverse of X over V will give you phi. Cosine inverse of Y over V will give you phi. And tangent inverse of X over Y will give you phi. Notice these phis, given certain X, Y, and V, are going to be the exact same. Same with these thetas. Given a specific X, Y, and V, they are all going to be the exact same. Right, that's kind of a recap of what we have went over in the last video. The main portion of this video, besides me talking about being up late, is this problem right here that we're going to go through. Because this is going to be adding 3 vectors. Now, also, I'm not going to do additional problem. Think about this as also for your lab. This is going to be the part you do when you're doing the vectors by components. So, why am I drawing this? So I know at one point we do it with 2 vectors and then we do it with 3. This is going to be done with 3. 2 is actually a little bit simpler, no different. You just kind of take away one of the vectors, so it's no big deal. Anyways, I guess that's where I got it from. Okay, so let me make sure everything's right. We have these 3 vectors. We want to break each one down into the components. These are all forces, so this is again going to be really important when we get into chapter 4 and beyond that. So we're going to look at X component. We're going to look at Y component, which I have them vertically listed, but it's okay. So AX is going to be A cosine theta. So here's A. We got to take A, which is 100 newtons at 37 degrees. So I'll write over here. You know what? have the picture, so let me just enlarge this. Give me more space too. Alright, so I'll do a y component over here. So this is 37 degrees. So what directions are my A components? This direction and this direction. How? Because the arrows in those two directions. It's y and x, or north and east. You know, it's up and to the right. So for x component, we would do A cosine theta. And for y, we would do A sine theta. So what's A 100? Cosine 37. And then 100 sine 37. And then we can figure out the number here later when we go to the next step. B is, that's just calculator stuff. B, this is B, so you have 100 for your newtons, and then 150 degrees this way. But here's the thing, I don't want to put in 150, I'm going to put in 30. Okay, if I put in 150, it's fine, but it's easier in a sense to think about this as 30, so you know it's from your x-axis, and so you'll get B cosine theta, and by is B sine theta, and now in this case theta is changing because we can think about it as theta for A, theta for B. So B is 100 cosine 30, and here B is 100 sine 30. Now, which directions are these? Well, it's to the left and up, right? Because this is to the left and up. Well, up is positive. I'm going to call up positive. These both are positive because up is positive. This one's to the right and this one's to the left. I need one of these to be negative, so I need to make a decision. And of course, I'm going to do that, and so that's going to make B negative. If I would put in 150, that also would make B negative as well, but I just like doing it this way. Now, if we only had two vectors, if these were the only two vectors, we would stop there and move on to the next step. If we have three vectors though, so we'll add another vector and do the same thing. If we have four vectors, we'll keep going. You know, if we have 100 vectors, we'll go all the way down to as much as we can. We don't ever really have that many though. So C would be C cosine theta, which that would be theta C, and this would be C sine theta C. So C is 80 newtons, so 80 and 80, and then we'll do sine and cosine, but we need to get this angle. So this is 233 degrees. This is 180. So that means this is 53 degrees. So cosine of 53, sine of 53. Okay, so let me just be clear. That was 150. This is 30. And then this is 53 degrees. Okay? And this whole thing is 233. Alright, so now this is down and to the left. I've determined both of these to be negative, so C is going to be negative on both sides. Okay, so now we go to the next step. Again, if we had two vectors, we would jump to this step and not do C because we won't have C. If we have four vectors, we'll do one more vector and then jump to this step. But this step doesn't change. It's always going to be next. And literally, it's just adding these vectors. So we want to find out what these numbers are and then add them together. All right, so let's do that. I'll move it over here so I can have everything seen. So turn it on, make sure the right mode. Alright, so we'll start with 100 cosine 37, 79.86. Okay, so now 100, I'm not going to even put in the negative sign because I know it's just going to stay negative. Cosine 30, which is another reason I don't do the 150, is because I don't want to get confused with the negative signs. So 86 point, what's that? 0.6. And then 80 cosine 53, 48.15. That's going to be negative. That's going to be negative 48.15. Okay, now I got to add down these three. Now, normally, I'm breaking these down to show you what I'm doing. Normally, what I would do in order to avoid a rounding error is I'm just going to put them in. So 100 cosine 37, because I know these are exact, minus 100 cosine 30. I'm minusing it because I know that's going to be negative. And then minus 80 cosine 53. Again, negative 54.88. Which we can kind of make sure on this. 48.86. So if we add these together, we get a negative 7. And that'd be about negative 55. So about that. This side, do the same thing. 100 sine 37. I'll write these all down at the same time. 100 sine 30. And then 80 sine 53. So 60.18, 50, and 63.9. So 60.18, 50, and 63.9. This one will be negative. Alright. So same thing if I add down 100 sine 37 plus, now because I did it that way, I know that's going to be 50, so it's a lot easier to just type in 50 minus, and then 80 sine 53. So plus 50, these two positive, minus C, you get 46.3 or 46.29. Okay, so these are your components. So in this case, we're dealing with forces. I will label this as, Fx, force in the x direction, force in the y direction. Okay, just to be clear, this, if I add these two, we're looking at negative 13. Subtract that from here, about negative 47. So yeah, we're okay with there. All right, so now what we want to do. Pictures tell us everything. Y is 46. So let's say that's 46.29 from our origin. Our X is 54. So it's going to be a little bit longer than this, because it's higher, 54.88, and that's negative. And so our resultant is going to be something like this. Now, I'm going to tell you this right now. This is not going to be 45 degrees. I know that it won't be 45 degrees because the only way it will be 45 degrees is if these two numbers were the exact same. Not counting the negative sign. But if these two numbers were both 51, then it'll be 45 degrees. Because they're not, as y becomes a lot bigger, most of this angle is going to be up here, and so it's going to be higher than 45. As x becomes a lot bigger, it's going to be lower than 45. So this should be less than 45. Not much less because these aren't that far apart, but it should be somewhat less than 45. And that's the angle we want to find. Alright, so how do we find it? Well, just a couple more steps. A resultant f, which I'm going to call fr, is going to be that squared equals negative 54.88 squared plus 46.29 squared. And so we'll take the square root of that once we add those two. So I square that, then plus 54.88. Now I'm not putting in the negative sign because it's just going to square out. So 5154.63, and then take the square root. .79, so 71.8 newtons. Okay, it's newtons because all of these numbers are going to be newtons because we're dealing with forces at this point. Now, like I said, every vector you want to find your angle. It doesn't matter if I ask for it or not. I want it. So we're going to find it by inverse tangent of y over x. So in this case, it'd be fy over fx. So inverse tangent of, which one's 46.29 over 54.88. Now, like I said before, we don't have to put in the negative sign. We know where it's at. The negative sign only indicates where it's at. It's just going to end up giving us a negative number, which is going to tell us it's here to a point. It could be here over here, but we know it's here. So let's just leave off the negative and get a positive answer here. So 46.29 divided by 54.88, we get 40.15. And that will be degrees. And this is going to be above the negative x-axis. Okay, or we can report it from here, which means we have to subtract it from 180. So we can say that the angle is 180 minus that, 139.9. So the angle is 139.9 degrees from x-axis. And how much is 71.8? Okay, so let me make sure that there's nothing else with that. All right. So the next thing, let me minimize this again. So we went through that whole problem, including looking at the resultant already. As I said before, when we have two vectors or even multiple vectors, when you add them together, you get what you call your resultant. If we take the opposite side of this, that's what we call your equilibriant. I said that's when I was talking about the lab, because we're going to see these terms in the lab. So if I want to find this equilibriant, since I know it's this way, well, the equilibriant, which I'll just call it E, the magnitude is going to be easy. It's 71.8 newtons. It's just wherever this is. That, I mean, it has to be that direction. And it's actually that same size, but imagine that's the same size as that. The angle is going to be this angle here, or the angle all the way to here. These thetas are actually going to be the same. So this is not anything different. We just got to subtract it from 360 now instead of 180. Or we add 180 to this, right? So the angle from in this case is going to be 319.85 degrees from x-axis, and that'll be your equilibriant. So there's not much more math other than adding or subtracting with this. define this. It's just more of an idea behind this. So if we go back now to this, if we have, or even we can even use this. Person pull in this direction, person pull in here, person pull in there. If somebody can come up and match the forces and pull at this angle and pull at 71.8 newtons, whatever they're pulling on will not move. And it's going to be in equilibrium. That's the idea of the equilibrium. Okay, so that's the end of this section of chapter 3. Chapter 3 is probably the most intense chapter in all of Physics 1, actually. But it's a good background, and that's why I go into detail with vectors so much, because we will be using these in the next few chapters. So next chapter is two-dimensional. Actually, it's still this chapter, but the next video is going to be two-dimensional projectile motion. I think there's 2 of them because I already did those videos. And then we'll go into forces, and I actually already did those videos. I'm not doing this in order. And then just because, I don't know, there's certain chapters I like better than others. And then you do circular motion, which also will deal with videos. I'm almost done with that one. I actually did part 2 of that one, and it didn't save. So I gotta redo part 2. And then and there'll probably be a part 3 of that one as well. And then, momentum, and energy and then momentum, that should be the first section for momentum. Right. So any questions on these, always ask them. We can, if this is an online class that you're learning, we can do WebEx. If it's one that maybe we have labs together, you can ask them in labs. If it's a flip classroom, because I think I'm going to be doing the flip physics classes as flip classrooms, then in the future, then you can always ask, when you come in and to do the in-class work. I think the reason why is, I like to do the flip classes because these videos I can delete if I don't like it and redo it. I can't delete it if I don't like something I say in person. I can make mistakes every now and then and just make a sign error and nobody says anything even though they all saw it, and I get down to the end and it's not right, and nobody says anything until I find it and they're like, oh yeah, we saw that. So in these videos I can check my work, if I mess up, delete it. And you never see it. Alright, so I'll see you in the next chapter.